Hello students. Today's session we will discuss about benchmarks, which is a major component, or which are major programs, some special category of programs that are used for measuring the performance or for comparing the performance of different computer machines or different hardware devices. So benchmark, as the name indicates, it is actually just for comparison. So whether one system is better than the second one, or whether this is performing good when compared to the second one. So for this we require a mediator. A special program is actually required, which is called as a benchmark. So we'll see the details of benchmark and how it is being utilized in the performance evaluation of a computer system. So normally, I'll give some description initially. So if you want to compare two different machines, what we can do is use a program. I am having a program here. I am having a program available. I have written a program. Then this is a machine A and this is a machine B. Two machines are there. Now I want to check whether A or B is having a better execution time, or which is having a throughput. Throughput cannot be done by using this method, but which is having a better execution time. So what I can do is I'll give the same program to both A, and I'll give the same program to B also. The same program with same number of lines. For example, if you are having some 50 line code is available with this program can be given to both machines A and B. So A will be executing the program, and assume that it takes 5 seconds to complete this task. Similarly, the same program is given to a second machine B also, which takes 7 seconds to finish the task. The same program given to two systems A and B, it takes only 5 seconds and this take only 7 seconds. So from comparison of these two, we can see that the system A is having a better performance when compared to the system B, because it takes only less time to complete or execute a program that is written by the user, and that is given to both systems. Okay, so this was the earlier mechanism to compare two different machines. Similarly, for a second program, now if I am giving another program, for example P2, another program is given to the same two machines. One is given to A and second is given to B. This situation also assume that P2, a different program, that is for a different application, this program is given, and assume that A is taking it is taking around 8 seconds to finish that program, and the same program given to B, it is taking only 6 seconds. So for a different program, we can see that the machine B is having a better performance when compared to the machine A. Now this was the problem when we are simply evaluating, or we were giving our own program for evaluation or for comparison between two different machines. For some programs, one program may outperform, and for some other programs, the second machine may perform well. So that was the issue why we are not following that is why we are not following these simple programs that are given for this benchmark, that for performance evaluation and all. So there comes the importance of benchmark concept. So benchmarks are also programs. So normally it is not like the user defined programs. Special programs are designed so that the programs can be given to different machines, and so these are standard programs. These are standard programs that can be given to various machines for its evaluation, and these benchmarks are followed by various system designers, because any programs comparison between two different machines is not only depending on the program that we are giving, but these standard programs, benchmarks, so we are having some benchmark standards available. If you are using that, if the designer is using that benchmark program for the evaluation or comparison, they'll be getting a better result. There won't be any complication among different processes when they run the same benchmark program with two different machines. So the best choice of a benchmark is to measure the performance in real-time applications, such as so many situations we are using a compiler program. So this P1 compiler, the execution of compiler on this machine A and the compiler on machine B. So many situations they were using the real-time applications, like so for many programming languages they are using compilation. So compiler can be considered as a program that can be used as a benchmark. Now attempt at running programs that are much simpler than real application have led to performance pitfalls. That's what I was mentioning. Simple programs, if it is given for performance evaluation, it won't be giving a proper result on the performance of the or the comparison of different systems. So some of the example benchmarks that we are using is like they were using kernel programs, which are very small applications. Some kernel programs can be considered as a benchmark for comparison between two different machines. Similarly, sometimes we are using toy programs. Toy programs are simple programs like a sorting program like quick sort. Because sorting and all requires more looping and some comparison. So such type of program can be given to two different machines for having a better evaluation. So we are using some toy programs like quick sort and all for evaluation or comparison between two different systems. And similarly, we are using some synthetic benchmark, some artificial benchmark, that is again a set of fake programs. Some fake program is written just for comparison. It is strictly written for only this benchmarking purpose. It is written. So the program is given and the program will automatically check various aspects of means for both which all system to be compared. For these two systems, the same program will be given. The program will be doing a set of operations on both system A and B, and accordingly it will be producing the result on both A and B, and from the result we can say that whether the machine A is better than the machine B, or whether B is better than A. So we are using a lot of synthetic benchmarks also. One of the example of synthetic benchmark is most commonly used one is dry stone. This is called as artificial benchmark. So we can use some kernel simple real application programs like compiler and all. We can use toy programs like simple sorting and all. Similarly, we can use some synthetic, means it is not for a specific purpose. Some artificial programs can also be used for comparison between two different machines. Now we are considering about benchmark suites. Benchmark suites are actually collection of benchmark applications. A number of benchmarks. So one benchmark is actually a single program. Now a benchmark suite means a group of programs are actually residing. A number of programs or a number of suites are actually present within the system. A number of benchmark programs are actually sitting or that is residing within the system. So when we take a benchmark suite, it will be consisting of a number of applications. A collection of benchmark applications called benchmark suites are popular measures of performance of processes with a variety of applications. We will see one example later in this slide. So not only a single program, a group of programs, various categories of programs are together, and this will be given to two different machines. For example, for A and B, the same benchmark suite will be applied, and it will be running on both A and B, and based on the result of both A and B, we can decide where A is better or B is better. Now, weakness of any one benchmark is lessened by the presence of, so in this set of benchmark suites, if any one benchmark, one suite is not properly working, or if it is not enough, but others can be considered, because one suite is under failure will not affect that much on the entire benchmark suite, because we'll be having some large number of programs available within the benchmark suites. So based on the other, if one is under failure, then also based on the other available set of suites, they can decide the performance of the system. Now, the goal of the benchmark suite is it will characterize the relative performance of two computers, particularly for programs not in the suite that customers are likely to run. So it will give a relative performance or a characterization, so a comparative result will, because various options are being tested, various categories of programs are being executed simultaneously on both system A and B. So we can have a final, means a better report or an analysis of all the execution of the program can be created, and that can be reported, so that we can easily look into the contents, and we can verify whether which system A or B is better by applying this particular benchmark suite. Some of the example benchmark suites are one example, that is Electronic Design News Embedded Microprocessor Benchmark Consortium. One of the example benchmark suite is which is called as EEMBC. This one EEMBC, which is pronounced as Embassy, which is an example for a benchmark suite which consists of a lot of programs. So what are the contents of this Embassy? It consists of 41 kernel programs. System level programs are available. It is used to predict performance of different embedded applications. So the major contents of this Embassy benchmark suite is 41 number of kernels. Because this benchmark uses kernels, it does not have the reputation of being a good predictor of relative performance of different embedded systems. So this kernel programs are real-time applications are applicable for some specific category of embedded system only. But if you are using different embedded systems, it won't be that much effective. That is what it is saying. So that is why even if we are having such benchmark suite available, because of this problem, even this synthetic dry stone is still, even if we are having benchmark suites available, it still uses the dry stone, which is a synthetic or artificial benchmark that is already available. Some duplicate set of programs are available for evaluating the performance of various systems. So Embassy is a benchmark suite which can be utilized, but it uses special category of programs only, which can be only used for only assessing some specific type of performance of systems only. And another example of benchmark suite is a standard benchmark application which is called as SPEC. You might have heard about the term SPEC, Standard Performance Evaluation Corporation, which is the most commonly used benchmark suite, which is a better benchmark for workstations. The major workstations are major computer set of computers that are used for very crucial applications and all. So SPEC is a very good standard for, very good benchmark suite for evaluating the performance of various workstations. It covers many application classes. It consists of different types of. Previous case, it was only some certain set of programs, up to 41 kernels was available, but this SPEC covers various classes. Different types of applications are available within that benchmark suite, and this will be very helpful for evaluating all the aspects of the performance of a computer system. and the benchmark suites available within spec is actually available within the website www.spec.org. So spec is a standard benchmark suite which is called as Standard Performance Evaluation Corporation. Now the desktop benchmarks, the benchmarks which are used for evaluation of desktop system. There are two broad classes available for desktop benchmarks. One is general category processor intensive benchmark, and second one is graphics intensive benchmark. So this one will be focusing on the performance evaluation of the processor CPU alone. Second one is used only for the performance evaluation of the graphics properties of the computer systems. These two are applicable for only desktop PC system. Previous spec was actually intended for workstations. Here for a particular desktop we can use either processor intensive benchmark or graphics intensive benchmark. Now some of the example desktop benchmarks are given. By using the same spec benchmark consortium itself, they have developed some desktop benchmarks. Some of the examples like spec 2006 is a standard. So when they develop various benchmark suites, they'll be having their own applications, their own means the programs present within those spec will be differing from the earlier one. So you can see starting from spec 89, then comes spec 92, then comes spec 95, then 2000, then follows spec 2006. So this was the modification. So this was a set of suites, and some updations added. So when it comes to the recent one, there will be some removal of some suites from the earlier one, and some additional suites will be added to the latest one, just like having the creation of a new version of an earlier language, some modifications being added, something will be removed from the existing language. So in the same way for spec standard also they have several modifications added into the benchmark suite. Now spec 2006 consists of 12 integer benchmarks for integer related operations. So all the integer operations can be evaluated. So all these are dummy programs. Similarly, it also consists of 17 floating point benchmarks so that it can do some dummy internal floating point operations. So normally a processor will be taking more time to do any floating point operations. So it should have the provision for doing various floating point operations, and accordingly we can evaluate the performance of the system. Spec benchmarks are real programs modified to be portable and to minimize the effect of I/O on performance. So these are real programs, like we will see one example later. The spec actually consists of a set of real programs even that is related to Java or any similar, even related to languages also. It is having programs available. Many things are being written there and they can have the performance evaluation. It is useful for processor benchmarking for both desktop system and single processor servers. So earlier spec was only supporting workstations, but later these various versions of spec was introduced and they supported both desktop system as well as single processor simple servers and all that. Also the desktop benchmark or the spec can support a single processor server or simple desktop system for the performance evaluation. So this is an example spec details. So these are the descriptions, the types of programs available in a benchmark suite. But when we look at the right hand side, these are the programs. These are the programs available in spec 89. Now this is about spec 92, the programs available. Then spec 95, the programs available. Spec 2000, the programs available. Then spec 2006. We can see more programs are being added. So sometimes some programs are being replaced from one spec to another spec. Some, for example, GNU C compiler, spec 99, it uses GCC, but these for all these also they are following the same thing. And now for interpreted string processing, for spec 1989 it is using a program Espresso. Then for spec 95 it is using Perl. Similarly, several programs. So we cannot remember all these names. So these are the various category of programs. So XML parsing, they are using some programs. Then Go game they are using versions of different Go game. Video compression, different programs are being used by different versions of. So here, this video compression are not used in these spec 92 and 89, and these things are not available with these programs are not available during these spec benchmark suites. So all these programs, so all these are duplicate programs that are within the benchmark, and when it is given to a system, all these programs, so if spec 2006 is given to two machines A and B, all these programs will be executed within A as well as B, and it will produce a result. And based on these two results, one is the result of A and one is the result of B, based on these two results it can decide whether A is better performing than B or vice versa. Okay, so this is only sample types of programs that are available within the, or different suites for. So these are different suites that is available within this spec benchmark. Now we are having server benchmarks. So for single processor server, we can use spec 2006 that I was mentioning before. But for server alone, they have introduced several benchmarks, like for example spec CPU 2000. It uses spec CPU benchmarks to construct a simple throughput benchmark, because server usually focuses on throughput. So throughput oriented type of task or suites are available within these server benchmarks, where when we are having more processors available, we need to have multiple copies of running multiple copies of each of these spec, because if you are having multiple cores available in a single machine itself, now the same spec to be distributed among different cores available, different processors available within the same system, and how many results are being produced within a given limited time, all these things to be evaluated on all the system. So for server, the concept means the requirement is different than a single desktop system. In desktop system we are focusing on the response time, and for the server we are looking for the throughput, more tasks to be completed within a limited given time. Now based on this or within this server benchmark, we need to have a measurement called as spec rate. Spec rate is actually a special measurement that is applicable with the server benchmark for finding out the number of, or which is used for as a measure for the request level parallelism. Request level parallelism means how many requests are being sanctioned within a given time. So we need to evaluate that. As I was mentioning, execution time for a normal basic computer system, basic desktop system, this for server we require more requests to be completed within a given time. So for measuring that we are using a special measurement called as spec rate. So most server applications are and benchmarks have significant IO activity, that is also to be considered. So spec offers both a file server benchmark, that is for file access and all file related operations, and also supports web server benchmark, that is related to web related or related to web application programs. So for server, normally it goes through the network and goes to a server that is situated in a remote location. So sometimes we'll be sending some file sometimes we'll be receiving some file, sometimes we'll be passing the address through the web HTTP protocol, and also when it compares to normal PC, many programs to be added into the server benchmarks. So we are having the different suites like spec SFS for file system, and web for web related. For exclusively for web server, we are having a separate benchmark suite also available. Now spec SFS, it is a benchmark for measuring NFS network file system performance. As I have mentioned before, it tests the performance of the IO system as well as the processor, because from the input to the network the file goes to the server, so it should have a performance evaluation of the IO system as well as the processor. Spec SFS is a throughput oriented benchmark, which is focusing on the number of tasks to be completed within a given time, and the importance is given to the response time also. Similarly, spec web simulates multiple clients. So here, what type of program they are applying in the case of spec web, they will be having duplicate clients available, and different clients will be simulated to have a communication with the server, and they will see how many requests can be sanctioned or responded by the server. So spec web is always deals with the network and the server connected to the network. Similarly, specifically for web applications that is written in Java, we are using a special benchmark that is called as spec JBB, which is exclusively for the benchmark or the application that is web application that is written by using Java. All these are examples of various server benchmarks. Now, with server, we are also using one more benchmark that is called as transaction processing benchmark, or which is shortly called as TP benchmarks. It measures the ability of a system to handle transactions that consist of database access. So exclusively for database related communication with the server, we are using special category of transaction processing benchmark. As we know, database access is always deals with the transaction operation, which is a special category of operation exclusively for accessing the database content that is present in the server. Now they have formed a group that is called as Transaction Processing Council, and they have developed various transaction processing benchmarks. Some of the examples for transaction processing benchmarks that was developed by TPC, Transaction Processing Council, were TPC-A, TPC-C, TPC-H and TPC-E. So they are having their own features added into these separate benchmarks for exclusively for transaction processing operations. So that is all about benchmarks, which is a very common term used with the performance evaluation of various computer systems that is to be compared, and based on that comparison we can have the development of a new version or a new system. Now next point is, so that was about measuring. Now next point is about reporting the performance results. So based on the evaluation, we need to have the reporting, that is to be the report to be generated that is based on the performance evaluation of various computer system. So the guiding principle of reporting performance measurement is the reproducibility. As it is with any even for a project also, why we are creating a report is only for reproducibility. Later if we got some confusion or some correction on that particular project, we always look at the report that is with that particular project. So even with companies also, they are actually maintaining a report of every stages of their product development, and they are maintaining that record, because even if somebody else is coming and looking into that, they can also work on the same, so that they can also do some modification or correction on the same machine. So in order to have this reproducibility, we should have the performance evaluation, whatever evaluation that is being done using several benchmarks, to be reported. It lists everything another experimenter would need to duplicate the results. So it can be used as a reference for another experimenter also. So a benchmark report requires an extensive description of the computer. So all the description will be available within the report. The compiler flags how it was working on each stages, as well as the publication of both the baseline and optimized results. So it is not only providing the performance and final performance rate and all, it is also providing all the internal informations during the execution of all the suits present in the benchmark. So it will be giving all the information. So it contains the actual performance times shown both in tabular form. It will provide the tabular table data information for each input, what will be the output, how much time it is taken, what was the speed, etc. Then it will also show the graph, how it was being, so that we can have a comparison with the second system by looking at the graph itself. So it is providing all the data in the form of tabular table format or in the form of a graph, so that we can have a comparison. And also these reports are excellent source for finding the real cost of computing system. So by looking at this graph and tabular data, the designer or the other people who is trying to buy or want to develop a system can easily estimate the cost of the system. If it is having a good performance, they can decide the cost accordingly. If it is having a less performance, they can also decide the cost accordingly. So always this reporting is always a required thing for any system design or any product design. We require a report, and for the benchmark performance measuring or performance evaluation also, we always require a report to be generated for further evaluation or for further checking and all. Now summarizing the performance results. So consumers trying to choose a computer will rely on performance measurement from benchmarks. So normally, if a company wishes to buy some 100 computer system, they are simply not going to the shop and they are buying 100 system together. They always wishes to look into the summary that is being formed with the support of a benchmark. So they'll be having benchmark comparison evaluation that is already being done. So they need to have a summary that is to be given to the consumer, so that they can have a comparison and accordingly they can choose the product. So once we have chosen to measure performance with the benchmark suite, we would like to be able to summarize the performance results on the suite in a single number. So in the report they are actually providing all the details, but finally from the report we need to have a summary by specifying the final, means the speed, execution, memory requirement, time taken, etc., etc. All these general idea that a consumer can easily understand must be added into the summary of the performance result. So a straightforward approach to computing a summary result will be to compare the arithmetic mean of the execution times of the programs in the suite. So for making the summary, for getting a particular value, what is the performance ratio, etc., they need to have they'll be getting different values for different suits. If they are running for a particular processor for a particular system A, a spec is being applied. They are working on some 30 to 40 programs on that spec, and for each of the program they will be getting some result, and they need to take the average time of all these programs present in the suite, and that can be taken as a summary. We don't need to provide all the informations, only the summary must be taken for that can be shown to a particular customer. An alternate would be to add a weighting factor to each benchmark and use the weighted arithmetic mean. A second method is, first one is just take the arithmetic mean of all the execution times. Second thing is add a weighting factor to each benchmark. For each benchmark add a weight and take the weighted arithmetic mean as the single number to summarize the performance. So both are equivalent. So here in the second case they are adding one weighting factor also into the different results produced by the benchmark suite. Now how we can select the weight while preparing the summary. One approach is to use weights that make all programs execute an equal time on some reference computer. So normally we are selecting the weight by using the weights that make all programs execute an equal time on some reference computer. So whenever we are applying this benchmark, we should have a reference computer also. We should have a reference computer. So in order to get the performance evaluation of machine B, we are actually taking a reference machine R also. So based on this reference machine only, so that we can get a clear picture on the performance details of B in reference with the reference machine. So that is one way of selecting a weight that is based on the reference machine in comparison with the reference computer. So rather than picking weights, we could normalize execution times to a reference computer by dividing the time on the reference computer by the time on the computer being rated. So we can also do a second factor. First thing is just by adding the weight in relation with the reference computer based on the time on that reference computer and the computer to be evaluated. Now we are having another option by dividing the time on the reference computer by the time on the computer being rated. So reference machine will be getting a time for the execution of a program to the time of the machine that is to be evaluated. So such a ratio will give a clear picture or a summary picture for the that is about the system that is to be compared in reference with another reference computer. So this ratio is actually called as spec ratio. So spec ratio can be considered as a summary that provides the performance result in the form of a single value to have a comparison with the reference or an earlier system. Now suppose that the spec ratio of computer A on a benchmark was 1.25. Spec ratio of a computer A on a benchmark was 1.25, which is higher than 1.25 times higher than the computer P. So as we were mentioning about performance and execution time before, here we are comparing between spec ratios. Spec ratio we are getting a value by comparing with a reference computer that I have already mentioned. Now suppose that spec ratio of a computer A, so this is computer A on a benchmark, we are using a benchmark program B Okay, so this program is applied to both A and another machine B. 1.25 times higher than the computer B. So A and B is there for both A and B. This benchmark program, so I will replace this with P. This is the benchmark program, is applied to both A and B, and we are having a reference computer also to be maintained. A reference computer should also be maintained to have to find out the spec ratio or to provide a better summary result of comparison between these two computer systems. Now here spec ratio of A to spec ratio of B, which is 1.25. That means A is 1.25 higher than spec ratio of B. So this is the result. This is the this statement is converted into formula here. Spec ratio of A is 1.25 better than spec ratio of B. So that means A is better than B. So how we have identified a spec ratio of A is better than spec ratio of B? There we are using a reference computer. So now which can be equivalent to execution time of reference computer to execution time of A decides the spec ratio of the system A. Execution time to execution time. Okay, so spec ratio is the performance in comparison with a reference computer. So execution time of reference to execution time of A, that is a spec ratio of A, divided by what is spec ratio of B? Execution time of a reference machine to the execution time of B. So for these A and B, so little more clear for both A and B, for comparing A and B, we are having a reference R. We are applying a common benchmark program. So spec ratio of A can be evaluated as the execution time of the reference to execution time of A. These two will be compared. Now to find out the spec ratio of B, these two will be compared. The execution time of R to the execution time of B. That is execution time B to execution time A. So these two will be removed while evaluating this statement. Execution time to, execution time of B to execution time of A, which is again equivalent to execution time can be converted into performance. Now performance A to, by taking the reciprocal here, performance A to performance B. So 1.25 is equivalent to what to say, performance A to performance B. That means the performance of A is 1.25 times better than the performance of B. Okay, so now from the summary, by applying a benchmark on two machines A and B, and we are taking a third reference computer. With the reference computer, we are taking the spec ratio of both A and B, that is execution time to execution time of reference and A, execution time to execution time of B, then that is it is converted into performance, and the performance of A to performance of B, which is 1.25 higher than the computer B. So this value, this 1.25 spec ratio A to spec ratio B will decide how better the system A when compared to the system B. So you need to have a third reference computer also. As I was mentioning before, this will be taken as a weighting factor. Now, because a spec ratio is a ratio rather than an absolute execution time, so it is only a ratio, 1.25 better, it is only a ratio. The mean must be computed using the geometric mean. So what is geometric mean, which is equivalent to nth root of summation of I 1 to n. Sorry, this is the symbol for geometric mean, I equal to 1 to n sample of I. It will take the geometric mean of all the sample suites. For each suite it will find out, for each program it will take that value and it will take the mean. That performance ratio will be selected and the mean will be, geometric mean will be taken. Okay, so as in the previous slide, it was mentioning like taking spec ratio of A to spec ratio of B. So this is a general ratio. So in order to get the entire, this entire value, that is an absolute execution time, we need to find out the geometric mean of the entire suites available within the benchmark suite. So sample I is the spec ratio for program I. So several programs will be there within the benchmark. So for program 1, a spec ratio will be there. Program 2, a spec ratio will be there. Program 3, there will be a spec ratio. If you are having 30 programs within the benchmark suite, for each of the 30 programs, that spec ratio will be available and take the geometric mean of those entire set of programs available within the benchmark suite. Now, the geometric mean ensures two important properties. The geometric mean of the ratios is the this is the same as the ratio of the geometric mean. The geometric mean of the ratios is the same as the ratio of the geometric. So these are actually equivalent. Similarly, the ratio of the GM is equal to the geometric mean of the performance ratios. That we can prove in our next slide. So just for getting an absolute execution time rather than a ratio, we are finding out the mean value for all the programs. So previous case was mentioning for a single program as a whole, but for different programs, if it is available with that benchmark, we need to find out the benchmark, means the geometric mean of the all programs available within the benchmark suite to get a single or an absolute execution time of that particular machine A or B. Now show that, as I was mentioning before, show that the ratio of a geometric mean is equivalent to the geometric mean of the performance ratios, and that the reference computer of spec ratio matters not. Okay, just for proving the ratio of geometric means is equivalent to, this is equivalent to, we are just going to prove that geometric mean of A to geometric mean B is equivalent to the geometric mean of the performance ratios. The ratio of geometric means is equivalent to the geometric mean of the performance ratios. So how we reach from this point to this point, that we are discussing. So geometric mean of A is equivalent to geometric mean of spec ratio AI to geometric mean of spec ratio BA, which is equivalent to spec ratio AI to spec ratio BI to altogether, which is again equivalent to, when it compares with execution time of reference to execution time, so nth root of square execution time reference to execution time A for this one, divided by execution time of reference to execution time of B for B, which is equivalent to execution time will go up, execution time B to execution time A, which is equivalent to, what is execution time BA, that is, which is equivalent to, when it is replaced with performance of, this will go here, performance of AI to performance of BA. So just conversion from the ratios of geometric mean of A and B to the ratio of performance means geometric mean of performance. Okay, so it is always clear. Geometric mean of spec ratio or the ratio of geometric means of two systems are equivalent to the geometric mean of performance ratios. So just a proof or show that the ratio of the geometric means is equal to the geometric mean of the performance ratios can be done by using this conversion from this formula to this formula. So that's it for now. So today's session we were discussing about the performance measuring, reporting, and how to summarize the result of summarize the performance evaluation of various computers that are to be compared, and how we can find out the spec ratio, and how we can convert that spec ratio into a geometric mean to find out a fixed value, an absolute time value, and finally we were looking into a proof for the ratio of the geometric means to the geometric mean of the performance ratios. So that's it for now. So all these things are actually a part of the designer who is trying to compare two systems to design a new system. So there they will be having benchmark suite programs. They need to have a reference computer, now to add a weight, and they need to have the two different systems that is to be compared. So A and B are two systems that is to be compared. We are having a third reference computer to which we are finding the spec ratio, and from the spec ratio we are finding the geometric mean, and the geometric mean will be compared with the means in terms of performance also, and these final ratio, this geometric mean value will be considered for the comparison between the performance of two different machines A and B. So next session we will see the other basic the quantitative principles of computer design by applying Amdahl's law. When we are applying some enhancement on a new system, what are the different things to be, what are the different effects of that enhancement, and how we can evaluate the performance based on the new design principles. So that's it for now. Thank you.